we look at parallel and also perpendicular lines. We have parallel lines and also perpendicular lines. We are starting with parallel lines. So we are told that if two straight lines are parallel, then their gradients are the same. The gradient of two lines which are parallel to each other is the same. So if the gradient of the first line is -2, it means that it will be also -2 for the gradient of line number 2. If the gradient of the line, line number 1 is +4, this means also the gradient of line number 2 will be +4. So we are told that then the gradients or their gradients are the same. So if M1 and M2 are the gradients of the two or of two parallel lines, then M1 is equal to M2. Now, what kind of lines are parallel lines? Parallel lines are lines which do not meet. So if these two are two lines, this is line number 1, this is line number 2, these two lines are parallel to each other. It means that the two lines, even if we extend them, we continue, those two lines will not meet. Those two lines will not meet. So the two lines are parallel to each other. So the gradient of line 1, the gradient of line 1, meaning this line, it is the same as the gradient of line 2. The parallel lines can also be like this. The horizontal lines, two parallel lines, these are parallel lines. Even if we do like this, these are also the parallel lines. It can be like this. It can be like this. These are still the two parallel lines. So these are parallel lines. These two are parallel lines. These two parallel lines. They all, as long as they are two, they have the same gradient. If there are three parallel lines, it will mean that all of them, they have the same gradient. So let us now go to examples under the parallel lines. After that, now we go to the perpendicular lines. We have a question which says, find the gradient of a straight line that is parallel to. There's this question. We have also the B and we have the C. We are finding the gradient of a straight line that is parallel to these equations. We'll start with question number 1. Question number 1 is, or question number A is, y is equal to x plus 3. Now, there is a line, there is a straight line which is parallel to this equation of the straight line. So I will name this one as my line 1. My line 1. If this is my line 1, it means that I have to also, the gradient for this line or for this equation will be gradient 1. Now, what is the gradient for this equation? Remember the gradient, the equation of the line, it is always in the form of y is equal to mx plus c, where c is the intercept. So in this case, our c is this, then our x is this. Now, what is our m? Our m, it's a number, or it is the coefficient of x. Now, in this case, what is the coefficient of x? The coefficient of x is 1. So the coefficient of x is 1 because this is the coefficient of x. So if a variable does not have any visible coefficient, it means that the coefficient is 1. If a variable does not have any visible power or an exponent, it means that the power or an exponent is 1. So in this case, the variable x, or the gradient for m1 for this line 1 is 1. Now, if there is another line which is parallel to this, it means both of them they are carrying the same gradient, because we have learned that gradient 1, it is the same as gradient number 2. So if gradient 1 is equal to 1, because we found it is 1, this means that gradient number 2 is also 1. So this is the answer for the second gradient. So gradient number 2 is 1. Gradient number 2 is 1. So that is the answer we have. Let us now go to the next question, which is question number B. Instead of working out question number B, I've gone straight to question number C. Question number B, you are going to do it yourself. You try this one, then you send your solutions. We go to question number C. Let us find the gradient. So the first thing, we have to rearrange question number C into the form of, in a standard form, okay, or in a form of the equation of the line. This means that we have to make y become the subject of the formula. So how are we going to make y the subject of the formula? We are going to write it as negative 2y is equal to, we'll start with this, because what starts is the term with the x variable. So we are going to have negative 6x, then now 7 comes in, minus 7. What I've done, I have moved this 7 to the other side. I've also moved this positive 6 to the other side. If positive 6 goes to the other side, it becomes negative. And this one also becomes negative, because the additive inverse of 6 is negative 6. The additive inverse of positive 7, it is negative 7. Now, to make the y become subject of the formula, we are going to divide both sides by negative 2, even here by negative 2, and there by negative 2. So, in this case, negative 2 into negative 2 will just remain with y, and y is equal to negative 2 into negative 6. We are going to have positive 3. Then we have plus 7 over 2. Because negative divided by negative, the answer is positive. What is the gradient of C? The gradient of C, which is line 1, I'll call it line 1, is equal to 3. Now, the question is, we are finding the gradient of the straight line, which is parallel to what? To line C. So, we have learned that if two lines are parallel to each other, it means the gradient of the number 1, it is equal. It is the same as gradient number 2. So, therefore, gradient number 2 is also 3. Why 3? Because gradient number 1 is 3. So even gradient number 2, the answer will be 3. So this is what we have under this question. Let us try another example that comes under parallel lines. Then later on, now we go to perpendicular lines. Another question. Question number 2, or example number 2. Find the equation of the straight line that passes through the point 4,6 and is parallel to the line A. This is the line. B. This is the line. Solutions. So, what will be the solution? First of all, we are finding the equation. So, question number 1, we have the equation given, which is y is equal to 3x minus 8. This is equation number 1. or line number 1. Now we want to find the line number 2. Line number 2 should be y is equal to mx plus c. This is line number 2. Now where is this line number 2 passing? It is passing through 4, 6. This means this is the value of x, this is the value of y. Now when we come to this one again, what is our m? Our m, because these two lines, this line and this line, are parallel to each other, it means that they have the same gradient. So what is the gradient of this? The gradient of this, it is c, it is 3. So our m2, let me put it this way, our m2, meaning the gradient for the line number 2 is 3 also. So this means that line number 2, or equation we are finding, it will be 3x plus c. Now we need to find the value of c. We can find the value of c by making the c the subject of the formula. How? By substituting where there's x, we substitute it with 4, and where there's y, we substitute it 6. So it will be 6 is equal to 3, open bracket 4, then plus c. So it will be 6 is equal to 12 plus c. So it will be 6 minus 12 is equal to c. So it will be negative 6 is equal to c. So therefore our y will be 3x minus 6. This is the answer for the equation of the straight line that passes through 4, 6, and it is parallel to this line there. So that is what we have. Let us now go to the next question. Let us look at the next question, which is question number B. Question number B. We are still finding the same. This is line number 1. By the way, this line number 1 has to be rearranged. We make y become the subject of the formula. So it will be y is equal to, we will start with this. Now, once this one comes to the other side of the equal sign, it changes to the opposite or to its additive inverse. So it will be negative, remember this one is 2y, it will be negative 3x, this other side, then plus 4. What do? We are going to divide by 2, negative 2 I mean, and this other side by negative 2, and the other side by negative 2. So we are going to have y is equal to 3 over 2x minus 2. Which one is our gradient there? Our gradient 1 is 3 over 2. So we have known gradient number 1. Now we go to, so meaning this gradient number 1, it is also the same gradient for the line we are looking for. What is the line we are looking for? So where there's m, I'm going to write 3 over 2 and the x plus c. Let us now find the value of c. Since this line, it is passing through 4, 6, meaning where there is x, I'm going to write 4. Where there is y, I'm going to write 6. So I'll say 6 is equal to 3 over 2 multiplied by 4 plus c. Then 2 into 2, the answer is 1. 2 into 4, it goes 2. So 3 times 2, the answer is 6. Now this 6 will go to the other side. So it will be 6 minus 6 is equal to c. And the value of c now will be 0. So therefore, we are going to say